Today we will discuss the joint density of random variables x and y via examples. So the first thing I want to do is I have one random variable x and random variable y. The joint density is given by f of x y is x plus y. So I want to first verify that this is a legitimate joint density. So the first thing is you verify is that the first point is f of x comma y is always going to be non-negative for all x and y in R2. Why is this the case? Because if you look here, when you have x plus y, when x is between 0 and 1, that means it's always non-negative because I'm adding two non-negative numbers. And the other one is when it's always 0, so it's otherwise, so it's always bigger than or equal to 0. So the density function is always non-negative. So I use the word density function before verifying it, but I'm going to verify it's a legitimate density function. The second thing is I want to verify is the following, that the integral of minus infinity to infinity, right, of f of x comma y dx dy is equal to 1. This we have to verify. So why is this true? Let's verify it slowly. So the first thing you notice that the function is 0 outside the unit square. So that means this reduces to, in this case, verifying only 0 to 1, f of x comma y dx dy is 1. Okay. That's all need to verify. So let's say need to verify. Let me move this down a little bit. Let's check it. Go here and say need to verify. This one. But what is this now? This is going to be equal to the same as saying, so 0 to 1, and I have x plus y, I have dx dy. Okay. So now to do double integration, you have to be a little bit careful. So what we do is we just look at the first guy. The first guy is only x. So let's color it x. Let's make it orange, and let's leave the y as y. Let's call the y as white. So the y is going to be constant for the orange people inside. So that's the first thing you identify. Okay? So for this part, y is going to be a constant. So you just think of it as f of x plus y. F of x y is equal to x plus y. X is the integral variable integration, and y is a constant. So what happens? This imply, so this inside integral, if you think a little bit, if you do by 12th class mathematics, this is just going to be x squared by 2 plus y is a constant, right? So we go back to y is a constant, and you have x. So y times integral of y dx, when y is constant, is just y times x. This should be in orange. Let me go and correct it. And then I close the integral. So that's the x integral is done. But of course I have to do it from 0 to 1. And then this whole whatever I have to integrate it with regard to y. That's one. Very good. So what happens here now? This is the same as, this is equal to this, the same as integral from 0 to 1. The inside person, now I'll change everything to white. So if I put x equal to 1 here, I get 1/2 plus y times 1. That's the first term, and 0, everybody becomes 0. So this I have to integrate with regard to dy. That's what I'm going to do. So now this is going to be what now? This is integral from 0 to 1. The integration is linear. So it's 1/2 dy plus integral 0 to 1 of y, 1/2 dy with integral 0 to 1 of y times dy. So that's equal to what now? This is going to be equal to y by 2 from 0 to 1, and this is just y squared by 2 from 0 to 1. And that's just 1/2 plus 1/2, and that's equal to 1. So therefore, here I should not put implies, therefore, so now we verified that this is equal to 1. So that means we verified this particular step. That is that the density is non-negative and it is 1. The third thing we have to verify is that it is piecewise continuous. But that I will assume that you can sort of try it yourself. So this is like exactly f is piecewise continuous. Maybe handwriting is also good again. Let me make it clear. Piecewise continuous. Very good. So this I'll leave as exercise to try it. So we'll put a little pink here. So now we verified that this is the joint density of random variables x and y. So what does that mean? That means we know that the chance that x less than equal to, let's say, alpha, y less than equal to beta is given by integral from minus infinity to alpha, or I should put the y outside, so minus infinity to beta and minus infinity to x, and then of f of x minus infinity to alpha of f of x, y, dy, dx and dy. Okay. And again, whenever we do this, let's make the x guys as orange, so all the x people as orange. Then all you do is just think a little bit. So this whole thing, you always integrate out the x integral, keeping y constant. What's going on? Let's see if it comes correctly now. Very nice. X is also orange. So whenever you integrate out the x, you think of y as a constant. Or you can integrate y first and x next. Then also same way, you make sure that you whichever variable integrating, you keep the other variable as constant. That's how you calculate this probability. The second thing is, once I know how the joint probability of x and y are behaving, then I would like to know how the individual marginal density. So let's look at what's called the marginal density of x. Okay. So what does this mean? This means I need to find the function x f such that in the following sense, the probability of x less than equal to alpha is given by integral minus infinity alpha f sub x of x dx. So I need to find this guy. So since I've kept everything in orange, let me make all the x's orange again. So I want to find this. So how do I find this? So one way to do it is that you can differentiate this this about person right here, and keeping letting beta to be infinity and differentiating with alpha. We can do that. Or we also know from our earlier learnings that the joint density is just the integral over the other variable. So the marginal density integral over the other variable. So here we do. Let's just do that. So now we know from f sub x of x is going to be the integral of minus infinity to infinity. So let me write this in y. In white, sorry. It's just the integral from minus infinity to infinity of f at the point x is now in orange, y is going to be integral in dy. So I want to integrate out, keeping x fixed. Now again, I know my density is only positive in the unit square. So I come down here again. So here I come down. Here this is going to be equal to the integral again from minus infinity to infinity, and inside will be x plus, again this is going to be plus y dy, and it's not going to be in the range, not going to be everybody, sorry, only in the interval 0 to 1. Otherwise the density is 0, right? So 0 to 1. So I put 0 to 1. Again, x is a constant, like we thought before, so it will be x times y plus y squared by 2 from 0 to 1. And that's going to be equal to what now? It's going to be equal to x. So x is in orange again. So, x in orange plus this guy is going to be just 1/2. So the marginal density of x is just 1, and this is only when x is between 0 and 1. And it's 0 otherwise. That's the marginal density of x. Similarly, let's try and calculate the marginal density of y. How do you do that? So again the same way. So let's go the marginal density of y, we keep that in white. So marginal density of y, that is, we want to know exactly how to compute the probabilities of y. So that we already know. We know that if you want a function, density function, so that y less than equal, let's say some beta, is given by minus infinity to beta f sub y at y dy. So it's going to be equal to what now? It's going to be equal to, so now how do you find this f sub y? We already know that f sub y from before, we know that f sub y at y is going to be the integral from minus infinity to infinity, right? Now I'll have f, so I'll write this in f, I'll write this in orange for it's easier, right? It's going to be minus infinity to infinity. I have to integrate out the x variable and keeping y as constant, y times dy. Again the same thing applies. This function is going to be equal to integral from 0 to 1, otherwise 0, of the function x plus y. So I'm going to integrate again, I made a mistake here, it's dx. So x plus y dx. Now this again, as we know how to do this, it's just x is a variable integration, y is a constant, so it's going to be x squared by 2 plus you have y times x. And this you have to run it from 0 to 1. Therefore, again we find out, we convert everything to white right now because we want to, we find out that f sub y at y is equal to, so it's 1/2 plus y, and then y is between 0 and 1 and 0 otherwise. Very good. So this is one formula we have for f marginal for y. We come up here, we know this is the formula for marginal for x. And this is the joint density you start off with. Very good. So one may ask if x and y are independent or not, because they have some dependency in x and y. Let's see. So independence means what? Independence means including many ways. So are x and y independent? Let's see. Are x and y independent? So this can be done in many ways. So one way we know how to do it is that by definition we have to check if the probability of x less than equal to alpha and y less than equal to beta, these are all the events that govern the behavior of y and x. This should be equal to the probability of x less than equal to alpha times the probability that y less than equal to beta. That's what it should be. If this happens, then you're done with independence. But instead of checking this, we know that it's enough to check. It's enough to check not only this, but just check if the joint density of f of x and f of y splits up at, of fx and y splits up as f sub x at x and times f sub y at y. This is what you have to check. It's equivalent to checking this. That's equivalent to checking this. So now, but this, how do you check that now? Now, if x is not in 0, 1 and y is not in 0, 1, then we know that this person is 0, this person is 0, this person also is 0. So therefore 0 is equal to 0 times 0. So this check is open. So when x is not in 0, 1, it does seem like the prop is true. This 1 is true. Let's call this 1, 1 is true. But let's check if x is in 0, 1. So that means 0 is less than equal to x, less than equal to 1, and y is also between 0 and 1. Then what happens now? That means this person right here comes out to be x plus y, because that's the definition of joint density we saw. What is f sub x of x? Let's make it orange. What's that going to be? You go up here, f of x is x plus half. Let's write that down. So it's x plus a half. And what's this person going to, let's leave it in white. What's it going to be? This is going to be also y plus a half. So it's this times y plus a half. But clearly x plus y is on this side is x plus y. This is clearly not equal to, on this side what do I have? I have xy, right? X times y. I write everything in orange, or maybe I'll be careful. X times y plus y by 2 plus x by 2 and plus a quarter. So clearly these two are not equal. How do you verify that? You just take, for example, let's say take x equal to 0. So take x equal to 0, y equal to 1. So it's not true. This is not true always. This is not true. So this side is 1, which is not equal to this side is 1/2 plus a quarter. So in some sense, this implies that x and y are not independent. So if the densities don't multiply out, then the random variables are not independent. They're dependent. So there's some difference between x and y.